has a picture, a symbol, and has four parts. It's called a pictograph. Stand by.
Learning mathematics is quite fun and tricky. Mathematics enhance our skills as it is present in our everyday lives without even noticing it. In this course, we also need to learn and understand the graph use in presentation. And pictograph is just some of its parts that we are going to discuss. Now, I'll give you an idea what is a pictograph. So, pictograph is a graph that uses pictures or symbols to show data. This is to help in visually formatting statistical data and help in representing the data visually interesting and easy to understand. This can be useful as well for representing a large amount of data. In this lesson, initiates the development of skills in reading and understanding data in the forms of simple pictograph.
Did you know that the invention of writing started with pictures? That's right. During the first few centuries, humankind used pictures to convey information. Pictographs are based on the same principle that humans have been using for centuries. In mathematics, a pictograph, also known as pictogram, is the pictorial representation of data using images, icons, or symbols. We can represent the frequency of data while using symbols or images that are relevant by using a pictograph. Pictographs are one of the simplest ways of representing data. A pictograph makes use of pictures, symbols to express the meaning of statistical information. We must make use of pictograph cautiously because the graphs may, either unintentionally or on purpose, misrepresent the data. Thus, it is essential to make it visually accurate. A pictograph helps in expressing a large amount of data in a simpler form. Furthermore, the symbols in them help in attracting attention and give a smart way of representing data. In fact, they are quite easy to read since you get all the information in one glance and do not need a great deal of explanation. Whenever pictographs are drawn, they should look visually correct. As most of the time, the data is interpreted visually. Different pictorial representation of data such as bar graphs, line graphs, pie charts, and so on are available to easily interpret the data. Pictographs were used all over the world since 9000 BC and became popular around 4000 years later when they began to develop into logographic writing system. But the first pictorial signs appear in 30,000 BC in the form of cave paintings. Thank you.
Good day! I will be going to discuss some of the unfamiliar terms that it is based on our topic, which is pictograph. So what is pictograph? It is an ancient or prehistoric drawing or painting on a rock wall. One of the symbols belonging to a pictorial graphic system. It has been used in Egypt or Mesopotamia since 3000 BC. It is a pictorial representation of statistics, for example, chart, graphs, and a computer screen. Next is statistical information. It's the data that has been recorded, classified, organized, related, or interpreted within a framework so that meaning emerges. So, statistical information means it is the analysis, interpretation, and classification of data. Next is pictorial representation. This means that the children are looking at the picture to help them solve the calculation. It is how the person visualize or comprehend that pictures through visual representation by computing it or conducting solving problems. Next is logographic writing. It's the oldest type of writing system. Logographic writing systems use symbols that represent or complete word or morpheme. Example of this logographic writing is a Chinese languages. They have many characters or symbols as you can see, and also other languages. Next is cave painting. It encompasses any parietal art which involves the application of color pigments on the walls, floors, or ceilings of ancient rock shelters. It is most commonly used by our ancestors. They use it because they record such history events or our culture. Is statistical data, the study of the collection, analysis, interpretation, presentation, and organization of data. This is how we're going to arrange our data promptly, for example, from A to Z. And this means the organizing a data based on statistics. Next is sum. It is the result of adding two or more numbers together. Next is vaccines. It's a preparation that is used to stimulate the body's immune response against diseases. Since vaccines is included, this is one of our sample problems. How many people who got vaccinated. Next is frequency of data. It is a particular value in the number of times that value occurs in the data. Graphs, a diagram showing the relation between variable quantities, typically two variables, each measured along one pair axis or right angles. Graph is one of the main example of pictographs. As what I have been mentioned earlier, graphs, charts, and also the computer screen. And lastly, data. It is a collection of information gathered by observation, questioning, or measurement. It is the part where we gathered all the questions and informations together in one output. And we can see some of our observations over it.
Hello everyone, I am A Grace and I am here to share to you guys what are the steps and procedures in making a pictograph. So first off, you have to collect data. Collecting data is obviously important in making a graph since it is where you decide about what category you should represent. It is also where you can list all the information needed in order to formulate and tabulate the graph. And next is picking a symbol. So picking a symbol should be accurately the same with your chosen category. Just like for example, your chosen category is all about vaccines, yet the symbol you're showing are balls. So it does not make sense at all. So you have to carefully choose a symbol, just like for example, you would choose injections for the vaccines. So in that way, they are related. And next is assign a key. Sometimes the frequency of the data is too high. Then one symbol cannot represent one frequency. You must set a numerical value that one symbol will represent. This numerical value must be written along with a pictograph. You will see in the example below that one picture of young girl represents one half of vaccines. That is an example of a key. And next one is to draw the pictograph. Final step is drawing your pictograph. Draw the two columns that represent the category and the data. Then draw the actual symbols that represents the frequencies. Remember that the symbols can be drawn as fractions as well as the frequency is not a whole number. And the last thing is to review the data. Make sure to always review your pictograph and make sure it correctly represents the information that you wanted to relay. Don't forget to check the labeling of your graph.
Good day everyone. Today I will show you guys a sample problem using pictograph. The pictograph here shows different type of vaccines and people who got vaccinated with it. There are adult women, adult men, a young boy, and a young girl. So the key here are a adult woman represents one vaccine, a adult man represents two vaccine, a young girl represents one half vaccine, a young boy represents 3/4 of vaccines. The question are, how many vaccines are used in Moderna and Johnson? 2. The total of vaccines distributed to young children. 3. Total vaccines distributed to girls.
Solution. Problem number 1. How many vaccines are used in A. Moderna, B. Johnson? A. The solution for Moderna vaccine for one adult woman is equivalent to one vaccine, one adult man is equivalent to two vaccine, one young boy is equivalent to 3/4 vaccine, and one young girl is equivalent to 1/2 vaccine. In this case, for Moderna vaccine, 4 adult women was given a shot of Moderna as well as 3 adult men, 1 young boy, and 1 young girl. Divide the people with the given equivalent of vaccine in a category. For adult women, divide 4, which is the adult woman who has been given a Moderna shot, with equivalent vaccine which is 1. That is equals to 4. For adult men, divide 3 with 2. For one young boy, divide 1 with 3/4. And for young girl, divide 1 with 1/2. Add all the answers and the result is 11.25 vaccine was used in Moderna vaccine. B. Solution for Johnson vaccine. In this case, for Johnson vaccine, 2 adult women was given a shot of Johnson as well as 1 adult man, 2 young boy, and 1 young girl. Divide the people with a given equivalent of vaccine in a category. For adult women, divide 2, which is the adult woman who's been given a Johnson shot, with equivalent vaccine which is 1, that is equals to 2. For adult men, divide 1 with 2. For young boy, divide 2 with 3/4. And for young girl, divide 1 with 1/2. Add all the answers and the result is 3 vaccine was used in Johnson vaccine. Problem number 2. Total of vaccine distributed to young children. According to the sample problem, 8 vaccine was distributed to young boys, which is 3/4 times 8 is equals to 6. For young girls, there are 6 vaccine distributed to them, which is 1/2 times 6 is equals to 3. Add 6 and 3, that is equals to 9 total vaccine distributed to young children. Problem number 3. Total of vaccine distributed to girls. According to the sample problem, 14 vaccine was distributed to adult girls, which is 1 times 14 is equals to 14. For young girls, there are 6 vaccine distributed to them, which is 1/2 times 6 is equals to 3. Add 14 and 3, that is equals to 17. 17 total vaccine distributed to girls.
There are 11.25 Moderna vaccines used in a day. There are 6 Johnson vaccines used in a day. A total of 7 vaccines were distributed to young children in a day. A total of 7 vaccines were distributed to young children in a day. A total of 7 vaccines were distributed to young children in a day. A total of 17 vaccines were distributed to girls in a day.
Since there are 4 adult women, we have to use 4 Moderna vaccines. In men, one man is equivalent to two vaccines, hence we came up with six. One young boy is equivalent to three-fourths vaccine, and one young girl is equivalent to one-half vaccine. We added them all, therefore we got the answer of 11.25. There are two adult women, so we use two vaccines. There's one adult man, so we use two vaccines, since one man is equivalent to two vaccines. There are two young boys, and since one young boy is equivalent to three-fourths of the vaccine, we use one and one-half of vaccines. There's one young girl, hence we use one-half of the vaccine. We summed it all up, and we got the total of 6. Therefore, there are 11.25 vaccines of Moderna that were used and 6 Janssen vaccines that were used. There are 8 young boys in total and 6 young girls. Since only three-fourths of vaccine would be used among the young boys, we multiplied three-fourths and 8 and we got the total of 6. For the young girls, on the other hand, only one-half of the vaccine would be used. Hence, you multiplied one-half and 6 and we got the answer of 3. We added 6 and 3 and got the sum of 9. Therefore, a total of 9 vaccines were distributed to young children. There are 14 adult girls and 6 young girls. Since there are 14 adult girls, we multiplied 1 and 14 and got the answer of 14. Since only one-half of the vaccine would be used for the young girls, we multiplied one-half and 6 and got the total of 3. We then added 14 and 3 and we got the sum of 17. Therefore, a total of 17 vaccines were distributed to girls.